shouldn't have talking. That is going to be it. All right, so, yes, sir? Okay, hopefully it'll be at the very end of the day, you think? Probably so. That's what happens. Well, it'll probably be at the very end of Miss Elkins, if I have to guess. Yes. Alright, so let's take a look at this. Alright, so we talked about our strategies with multiplication. What was our first strategy? Nope. We multiplied by multiples of
10, 100,000.
good, which is where we used our what? Basic facts. Alright, then we moved to something where my numbers didn't start out ending in a 0, but I did something to change them, and that was what? Good. And then yesterday we talked about area models and partial products, which is where my 3 steps come into play. Everybody, what are my 3 steps?
Decompose, multiply, add.
Good. The good news is today's lesson, Robert, check your page number because I don't think that is the right one. Today's lesson is going to still use those 3 steps. Alright, so Amber, let's have a seat, please, ma'am. These guys have got to fend for themselves. Alright, so Kaylee Joe is going to read the paragraph underneath the distributive property. But first, everybody say, distributive property.
Distributive property.
Good. Alright, so Kaylee Joe, whenever you get ready.
The distributive property can be used to multiply greater numbers. It combines addition and multiplication. First, the numbers are decomposed or broken down into parts. Then, the parts are multiplied separately and then added together.
Alright, so Kaylee Joe read to us what the distributive property is. So underline the distributive property, underline that yellow. Alright, so there's my distributive property. Now, what does the distributive property combine?
Greater numbers.
I'm asking you questions. Very good. I'm asking you questions from your paper. All you have to do is look down at that paper. Boys and girls, what does the distributive property combine?
Multiplication and addition.
Hang on. Next 2 pages. Because you got to tear, yep. All right, now, look right here where it says first. Underline first. All right, that's fine. Yes, sir. Or, well, you might want to underline it on top of that. I said 2. You got to get yours too. Y'all, you got to stick those back in there because we're going to need those. Y'all have got, this is one of our problems again with reading and paying attention to what we're doing. You have got to pull out the right page numbers. This is a part of our reading and being careful with what we're doing. All right, so everybody underline first. It says first the numbers are what?
Decompose.
Decompose. What does decompose mean?
Breaking apart.
Yes, first the numbers are decomposed. Then the parts are what? Multiplied separately, and then what do?
Add together.
Well, that sounds familiar. What was my first step?
Decompose.
What was my second step?
Multiply.
What was my third
Add.
step? So even with the distributive property, you've already been doing the distributive property. It's just we used what to help us out? Area models. Good. We use area models and our partial product to help us out. Now with the distributive property, we're going to try and eventually do this without the area models. The distributive property is just like the associative property that, what's my special word for the associative property? Groups. What do you see with the associative property?
Parentheses.
Alright, good. What's my special word for the commutative property?
Order.
Good. Special words for the identity property multiplication? Times 1 and the zero property. Times 0. Now, here's a heads up though. The associative property, the special word is groups. Sam, put that up, throw it away. The special word is groups, right? What do I use whenever I have groups in math? Parentheses. Here's going to be a curveball. The distributive property is going to use parentheses as well. That's why we didn't learn about the distributive property when we learned about our other properties. We keep it separate so we don't get confused. You know with the associative properties that my groups change up, right? With the distributive property, you're doing those 3 steps. You got to look for the 3 steps. So what are my 3 steps?
Decompose, multiply, add.
So let's write those out to the side. Decompose, multiply, then add. My steps aren't changing. It's just now I've got to show you how to do these steps without the area model. And it's not hard, but it is a little bit more difficult for our visual learners like me. Whenever you take away the picture, it gets a little bit harder for me. But we're going to do it enough that hopefully it is not difficult for you. Alright, so let's look at example 1. So Berkeley, read example 1 for us. What should we be doing while Berkeley's reading? You better be following along. You better be reading it to yourself as she reads, because can we understand the problem if we don't read it? No, you've got to, just like the directions on the board. Are you going to understand what to do if you don't read the directions? You got to read, and not just the first part. Berkeley's going to read from the first word all the way to the
last word.
And we're not going to pick up our pencils unless we're underlining or circling, right? All right, so Berkeley, whenever you're ready, that name is Shelf Cora. Shelf Cora. Which really, let me tell y'all this. If y'all mess up a name, I'd rather you make up a name than worry about the name, because it really doesn't matter, right? It really doesn't matter. But go ahead. Uh-huh. All right. So before we start solving this, let's go back and talk about the problem. Shelf Cora hard bowls, how many eggs?
67.
Yes, a dozen is how many?
12.
All right, so let's write that. Let's just abbreviate. Well, no, let's write it out. A dozen equals to how many?
12.
Like a dozen eggs, there's 12 eggs. A dozen donuts, there's how many donuts? Write dozen for me. Now, here's where, because whenever you read this, it's like, but Miss Moore, it doesn't tell me to really multiply anything. Well, it does, because Berkeley picked up on what word? Well, no. What word did she ask about? Or say? Dozen. Dozen. Inside this word, dozen, is hidden what number?
12.
What does a dozen mean?
12.
All right, so above dozen, put 12. But that's the problem, Berkeley. Listen, shh, that's the problem. That's the problem. And I'm glad that you're asking why, because we need to figure out why. They say that we have a dozen, but do I have 1 dozen?
No.
I have how many?
6.
So I have 6 equal groups of
12.
So my problem is finding out my total for 6 groups of
12.
Does it make sense?
Yes.
Okay, good. But it's good that you're asking yourself these questions. Let me give you a news flash. Bella, make sure you're with me. Let me give you a news flash. In math, you aren't going to know the answers right away. You're not supposed to. Sometimes you get lucky and you do, but I'm going to challenge you. That end of the year test is going to challenge you. You're not supposed to know all the answers. right? That's what we want. We want to work on problem solving, right? I like the problem solving more than I ever like the answers. Because problem solving is what you're going to use in real life. Maddox will ask me, Mama, how in the world am I going to use this stuff that I'm learning in algebra, which is all letters and hardly any numbers? How am I going to use this whenever I get a job? And I'm like, you're probably not. It's not the math problem that's what's important. It's the what? It's the solving it. Because guess what? Life is going to hand out to you over and over and over again. Problems. And guess what you have to do?
Solve them.
And Mom and Daddy ain't always going to be right there to solve your problems for you, right? So that's what school's all about. Yes, you do get grades. Yes, math is important to know because you have to deal with money and stuff. But ultimately, you got to handle life's problems that are thrown at you, right? Okay, so you're all going to be great problem solvers. So here we go. So we have 6 dozen eggs. So I've got to figure out 6 times 12. Now listen, just like yesterday, y'all had better know what 6 times 12 is. But am I worried about the answer? I'm worried about the what? Problem solving. How do we get there? We know how to use our area model. So let's just kind of review this area model right here, which really they're probably calling that an array, but to me it's still an area model because I'm going to write on it. So let's look at this. If I was using this area model, which they've kind of filled it out for me, my 3 steps are, tell me again.
Decompose, multiply,
So
add.
I got to decompose, but look up here. They decomposed 12 already for us. They decomposed 12 into what 2 numbers?
2 and 2.
Wait.
10
10 and 2. And they put it here and they put it here. Make your line a little bit darker right here, okay? Now, you've got to remember these steps though, because it's the same steps without the area model. All right? After I decompose, what do?
Multiply.
6 times 10 is? 6 times 2 is?
12.
All right, now I've got to do decompose, multiply.
Add.
60 plus 12 is?
72.
Which we already knew. Are you writing with me, Lily? You're going to get behind it. If I have to tell you to pick up your pencil, if I have to tell you to write with me, you haven't been listening to every step and you're going to get behind. You can't get behind. And if these fancy fans, if I hear them, I'm taking them off. It's just like what we did yesterday, except here's what's different. All right? Do you see this part right here? Let's circle. Well, sorry, or put a box. No, not that big of a box. Just right here. Put a box around that. This is what we're learning out today. This is my area model without the area model, okay? It's not, let me take you through it slowly, okay? Because it's not hard, but it is a little bit intimidating whenever we first look at it, okay? So let's think about our area model. In our head, we have our area model that we just did, right? We have 6 times 12. Okay, boys and girls, let me ask you this. What number did we pull apart?
12.
Okay, we pulled apart 12, right?
10 and 2.
Okay, guess one, Bart? Well, they put that because that we broke it apart, remember, into 12. So they're just showing that if I add those together, I get what number. But it also drops down right here because after I multiply, what do I have to do? Add them back, right? Sometimes I'll put, and you could even put that there if you wanted to, but I just don't because I like to look at that box and think about putting it here. Does that make sense? Okay. All right, so we decompose first, right? Everybody agree?
Yes,
What which factor did I decompose?
12.
12. I pulled it apart into?
10 and 2.
10 and what?
2.
10 and 2. Now here's the thing. We've talked about 10 and 2, right? Once I decompose them, I don't need to do anything with the 2 of them together, right? Because I pulled them apart, correct?
Yes, ma'am.
Correct. So, those 2 numbers can't be in the same group together, got me?
Yes, ma'am.
You with me?
Yes,
Are you
ma'am.
sure?
Yes, ma'am.
They can't be in the same group together because I've got to keep them pulled apart, right?
Yes, ma'am.
So what did I decompose?
12.
So I'm going to put 10 here, and I'm going to come to my next group and put 2 here. I just decomposed my numbers, and instead of putting them in boxes now, I'm putting them in groups. Look back at your area model on your paper. Did I put my 10 and my 2 in the same box? No. So your 10 and your 2 can't go in the same group. Now, it doesn't matter if I get them switched up because of what property? Community. It doesn't matter, but for me, I like to keep it the same. And if you keep it the same, like me, you're less likely to mess up because my brain works like a 4th grader's brain. It's just the truth. It does. And if I need that repeating, the repeating's going to help you. All right, so what did I just do with my 10 and my 2? I
Broke it apart.
broke it apart, which my ass word is decompose. All right, so say my 3 steps again.
Decompose, multiply, add.
Good. So now I need to multiply, but here's the thing. I'm missing what number?
6.
I'm missing the 6 because whenever I decompose, to multiply, I had to multiply my 10 times what?
6.
All right. So put it. Right? And then my next thing that I had to do in my box was multiply
2
my
times
2 times my
6.
This is just like my area model, except it's like you're showing me each of the math steps now, which is a little harder because we're taking away the picture, and we like pictures, okay? Hang on, hands down, let's talk. Unless you have a question, let's talk through it. Question? Okay, but this is the first one. It's okay. As long as you're staying with me on each step, we're going to do more, okay? And also too, don't think that you have to understand it the first time we go over it. You might not. We're going to do more, okay? But that doesn't mean shut me off, right? And it doesn't mean thinking, I can't, this is too hard. Because once you think that, you're probably right. Whether you think you can or whether you think you can't, you're right. Right? Either way, it's your choice. Yes, ma'am?
I don't get how you said it was an area model, but it isn't.
Well, we're taking what we did in the area model, but we're leaving the area model behind, okay? So, we decomposed my 12. Here's my 10, here's my 2, right? Then up here, think about your area model. 10 times 6, there's my group. 12 times 2, 2 times 6. No, not asking for the answer. 2 times 6, here's my group. Now, after I get this figured out, 10 times 6 was what?
60.
So put it right here. 10 times 6 is what?
60.
Now we're just solving. What was 2 times 6 up here?
12.
Here. Now we're just solving. And then what did I do with my 2 pieces?
Add more.
72.
Nothing is changing. It just is going to look a little different because instead of the box now, instead of my box holding my numbers, now I have what holding my numbers?
Parentheses.
Okay? So, let me show you. Look very carefully, especially if this is confusing you. I had 6 times 12, right?
Yes, ma'am.
Here's the distributive property. Here's what it looks like. The distributive property says that I have 3 steps, right? What's my first step? Decompose. So what? Hang on. First step is decompose. What number do I decompose?
The multi-digit number 12.
Which is 12. So I have what? A 10 and a
2.
I decompose it. After I decomposed it, think about your area models. What did you do with your 10 and your 2?
Multiply.
You said 10 times
6.
not 10 times 2. Remember, those 2 can't go in a group together. What did I do first?
10 times 6.
And then what did I do?
2 times 6.
What is the whole point of having parentheses in a math problem? What do the parentheses tell
So
us to
it
do?
separates.
Well, it does separate it, but
So you know what to do first.
that's right. I've got to do it when?
First.
So that says after I break apart, I can't, what's my last step? I can't add these two until I do what first?
Multiply.
That's the distributive property. That's just what you did in your area model, except you're showing me with parentheses, okay? So, let's look back at this. So flip over to the back. Stay with me, I promise. It's gonna make sense, but we gotta get some more practice in, right? Okay. Shouldn't be talking. I've gotta bust up my little group of three back there because y'all are distracting my other kids. And that's not fair. Alright, so let's look at this. Ivy Kate's gonna read this example. While she reads, what's your job? Alright, good. Now look up at the top. It does tell you the definition of the distributive property. But all that definition tells me is what 3 steps?
Decompose, multiply, add.
The distributive property says that you can multiply the add-ins of a number. The add-ins of a number. That means that I took the number and pulled it apart. Because do you see my add-ins of 12 were what?
10 and 2.
These two numbers are called my what?
Factor.
What did we just say?
Your
Partial product.
What did we just say in that purple box? My add-ins. This is why math vocabulary is so important. Look at that definition in purple. The distributive property says that you can multiply the add-ins of a number. Well, where in the world did add-ins come from? Here they are. I have add-ins because what did I do?
add.
No. I decomposed my number. I decomposed 12 into what plus what?
10 plus 2.
And 10 plus 2 are called what?
Add-ins.
Because we're doing what to them? We're adding them. We're adding them, so they're called add-ins. Look at that definition. The distributive property says that you can multiply the add-ins of a number and then add the what? Products. Alright, so now Ivy Kate's going to read the example.
27 students are attending for a performance at the Children's Theater. Each
Admission.
admission ticket is $5. What is the total cost for the 27 students?
Alright, good. So I have how many students going? Alright, it says each admission, so that means one ticket is how much?
$5.
27 is my
Total.
Alright, so each admission ticket is $5. What is the total cost for the 27 students? So I know the cost of one ticket. How much does one ticket cost?
$5.
But I don't need to know one ticket. I need to know how many tickets?
27.
So I'm getting bigger, but I'm getting bigger in equal groups of 5. So what do I need to do?
Skip. 27 times 5.
I need to multiply. Write that. 27 times 5. Let's circle it. Before we do the distributive property, let's come over here and do my area model. So I think we've gotten pretty good at those. You're doing good. You are. You're getting it, Cooper. We're doing our area model out to the side.
2 parts.
No, not in this one, but good looking. Zana found that A. And she like pointed it out, which is good. It's good that y'all are seeing those words. For this one though, that A is just kind of needed, but it is talking about one children's theater, right? So you gotta listen, you gotta understand that that A is a math word because A is telling you that it's how many? One, right? Uh-huh.
Already broke the number.
Alright, well hang on. Let's go through this slide. Question? Uh-huh. Yeah? Because here, what's my first step?
Decompose.
So I gotta decompose. I only said first step. So what number do I decompose? My 27 or my 5?
27.
Alright, good. So I'm gonna decompose and I'm gonna put 20 there and
7 there.
7 there. Remember, my decomposed numbers go on the top, and then my what goes on the side? My single digit. Good. My 5 has to go on the side. Lily, you gotta stay with me. This classwork is gonna give you problems. All right, so decompose.
Multiply.
Alright, so now, what numbers do I multiply?
5 and 20.
5 times 20. So 5 times 2 is
10.
how many zeros?
1.
Alright, so 5 times 2 is 10, but 5 times 20 is
100.
alright, good. Now after I multiply 5 times 20, I'm going to multiply 5 times
7.
which is
35.
And then what do I do with my two partial
Add
products?
4.
Colton, don't be a distraction. 100 plus 35 is?
135.
So I know my answer. But I got the answer with my area model. I need you to be able to give me the answer without the area model using the distributive property. So let's look right here. I really hate that they built this in because we needed to practice writing it all, but I can't change it. Alright, so underline where we started. This is what we started with, right? Underline that for me. You're doing good. You're doing good. So what is my initial problem? What did I start with?
27 times 5.
So we agree that's how I started. But then I started using my 3 steps. So what did I do first?
Decompose.
Decompose. So hang on, pause right there. Which number did I decompose? 27. I decomposed it into what?
20 and 7.
Underline the 20 and the 7. That's where I decomposed it. And remember, the 20 and the 7 can't be in the same group, right? We're pulling them apart. They got to be in separate groups. Now, look at your area model. After I pulled it apart, I said 20 times 5. There's one group. And then I said
20 times 5 times 7.
I said 20 times 5. Then I said
5 times 7.
All right, let's try that again. 20 times 5, then
7 times 5.
Because I have 27 here. Times 5 times 5. What am I doing inside of these parentheses? And you don't have to circle it. What am I doing? Multiplying. Because multiplying is what step? 1, 2, or 3?
2.
2. Can I add then multiply?
No.
I can't add then multiply. My multiplication has to be in my parentheses because my parentheses say, hey, you got to do this first. Then, what my very last step is saved for is that middle right there. What's my very last step? Adding. So, let's solve this. 20 times 5, 5 times 2 is 10. How many zeros?
1.
All right, 7 times 5 is?
35.
100 plus 35 is?
135.
And listen, tonight's homework, you're going to be doing the distributive property. If you need to do, listen, we're going to get more practice. If you need to do an area model first, that's okay. Take your area model, do it first, then do the distributive property. Because this is going to help you. All right, so fill in your blanks for me.
But we don't have to use an area model.
You don't have to if it doesn't tell you to. Yes, ma'am?
What would happen if you added 40?
You would get a very different answer. Like, instead of doing 20 times 5, which is what did we say?
20.
Listen, 100. If we did 20 plus 5, we would get.
25.
So that would be a whole lot different, right? Than saying, so that was a very good question. Listen to Kaylee Jo's question. Kaylee Jo said, what if? So let me fill these in. All right, yours looks like mine.
Yes, ma'am.
Did y'all fill in the rest of the blanks for me?
Yes, ma'am.
Kaylee Jo said, okay, Miss Moore, what happened if I got them mixed up? Look at this. Let me fix mine. Now, you don't change yours, please. Don't change yours. Look up here. What happened if I accidentally added, then multiplied? Okay, so hang on. Yeah, you would get, but I want you to see. This is good. Hang on 1 second, darling. Instead of 20 times 5 being 100, 20 plus 5 would be what?
25.
And then 7 plus 5 would be
13.
Good job, Mr. Gunn.
12.
Mr. Gunn gets a gold star.
What?
Y'all gotta be quick. Y'all gotta do those. Now, I had 100 plus 35. If I get 25 and 12, you're telling me now I have to multiply. Well, Are we ready for that yet in fourth grade? So, just all of that to show you, we have those 3 steps for a reason. I put them in that order for a reason, because the distributive property, my area models, right? My partial products, all of those have those 3 steps, which are
Decompose, multiply, add.
very good. You have to keep them in those spots. What tells me in my distributive property that multiplication comes before addition? Look at your problem. There's something up there that tells me that it has to come first, Abby Kate. Very good. Everybody say it.
Parentheses.
The parentheses say, hey, look at me. You got to do me
First.
Solve me first, then we'll move on to the what?
Next.
The addition, yes. All right, so let's look down here. Now it wants us to use the distributive property to multiply, but it also wants us to what? Draw an area model. Now, they really don't give us a whole lot of room here, and I don't like that, but we're going to make the best of it. So let's look at number 1. We're still doing these together, because even though we're doing better with the area models, we're still a little not sure about the distributive property, okay? So, let's look at number 1. 12 times 9. Should you know that answer?
Yes.
But we're not worried about the answer, we're worried about the what? Problem solving, right? So, 12 times 9. What are my 3 steps again?
Decompose, multiply, add.
So, we got to decompose first. Well, which number do I want to decompose?
12.
Alright, so I'm decomposing 12. What am I going to decompose it into?
10
and 2. Remember, 10 and 2 have to stay separate, right? Now, Berkeley asked earlier, she said, Miss Moore, why did they put that right there? Because I don't usually put that. But they put it there to show that we decompose 10 and 2, and 10 and 2, if we put it back together, it would still be what?
12.
Alright, so I'm playing around with my numbers, right? And that's okay, because my 12 stayed at 12. Now, after I decompose, which they did for us, very nice of them, what do I need to do next? Decompose?
Multiply.
Alright, now next is just to multiply. Because remember, in our distributive property, we have the what around them?
Parentheses.
Alright, so what am I going to multiply first?
9.
9 times 10. Alright, hang on. Well, that's a basic fact. We won't do that in 2 steps. What's 9 times 10?
90.
Now, listen. We're doing our area model, but I want you to think. What 2 numbers did you just multiply?
9.
So that means those 2 numbers should be in a what together?
Parentheses.
They should be in a group together, right? Because we multiplied those 2 together. What are we going to multiply next?
9 times 2.
Which is
18.
18. You're good. You're good. Kind of sound like we said 5. You're okay. So, if I multiplied 10 and 9, and they have to be in a what? A group, parentheses. Then I multiplied 9 and 2. They have to be in what? Parentheses as well. So now you have your 2 groups. And then after I get my parentheses with multiplication, what comes last? Addition. So what do I do to these 2?
Add.
So 90 plus 18 is,
180.
which you should have known, right? So if you know the answer, you can kind of double check your steps. Good. Here's the thing though, and I think this is probably going to be the best thing to do. Because we just do not have a lot of room. Take one, pass it back. You don't have to put your name on it, but do put the date. Because you don't have a lot of room. I want you to put example 1. Put example 1. Take one, pass it back. Just put example 1. Don't worry about your name. Today's date is the 30th. Let's do our distributive property on this paper so it's not all jumbled down here. So, let's write example 1. And what did I start with? What's my initial problem? What's my first?
12 times 9.
Look at your paper. Point to number 1. How did my numbers start?
12 times 9.
12 times 9. So that's how I'm going to start in my distributive property. you're gonna write 12 times 9 equals, and we're gonna stop. We're not writing the answer because we're about to show the distributive property. What property?
Distributive.
All right, so look back at your area model. Have your area model right there, right? My first step was I did what?
Decompose.
Decompose. When I decompose, they have to be in separate
Groups.
All right, so I'm just going to put my what here, my 10, my different groups, my 10 here, and I'm just going to skip down and put my what? 2 here. I'm decomposing, right? Now, once you get really good at this, you're going to know that the first thing that you did was after you decomposed is you said, okay, 10 times 9. And then I multiplied
9 times 2.
9 times 2. But I can't leave them like that because I've got to have something that says my second step has to happen. My multiplication has to happen before I do what? And what is it, boys and girls, that we have to put around those? Parentheses. So instead of that area model, instead of my boxes, I have my parentheses, right? And I gotta leave this empty because after I decompose, then I multiply. Last I have to add. Right there in the middle. Now, what do equal signs tell us?
Both
Sides are
equal.
the same. Both sides are the same. Do you agree? Hang on, question. If it's not a question, hang on 1 second because I want to show y'all something. Do you agree that 12 times 9 is the same as 10 times 9 plus 2 times 9?
Yes.
Yes, because you know this, and we just solved this, didn't we? And it gives us the what? Same answer. So even though this looks really weird, it's okay because it's the same thing. So now, yes, ma'am, Advocate, what's your question? Well, that's a good question because this is the only thing I have over here. So if it's the only thing I have over here, then
You don't really need to.
it's the only thing there to solve, right? Now, I want you guys just to do this with me to see what happens. So what is 10 times 9? This is going back to our equations, remember? 90, drop down that plus sign, drop it down. And then, since they're both in parentheses, I can do those first, both of those. I just have to make sure I multiply before I add. Good. What's 2 times 9?
18.
And then I add 90 plus 18.
Which is 180.
Is it making a little bit more sense?